let's do a little practice with our angle pairs and identifying them and figuring out what we know about them. So it says use the diagram at the right are angle AFE and angle CFD vertical angles. So let's find AFE and CFD, and I'm going to find a highlighter actually. So angle AFE is here, CFD is here, and sure, look, we have that central vertex, and the lines are going, the rays are going in opposite directions, so we've got one going this way and one going that way. We've got a ray going here and here. So sure, those two angles, here and here, are vertical, and they are congruent. So they are vertical angles, which means that angle CFD is in fact 62 degrees. And so it says here the rays of AFE are FE and FA. The rays of CFD are FC and FD, FE and FC are opposite rays. FA and FD are opposite rays. And that's how we know that they are vertical angles. Okay? What can we mark as, this is just making a conclusion, looking at a diagram in geometry, we often have to do that. Can we conclude that they are congruent, that TW is congruent to WF? So it says let's circle the items that are marked as congruent. Well, TW is congruent to WF. It's marked. That's marked that way. So we can conclude that it's marked. We've got tick marks. So we can conclude that those are congruent. All right, next page. If two angles form a linear pair, whoops, let me slide that down, they are supplementary. So linear, remember, means a straight line, which is 180 degrees. So we know that if A and B form a linear pair, then that is 180 degrees. And that would be like saying we've got our line right here, and we've got angle A, and we've got angle B. Well, we know that when we add those together, that's going to give us 180. So that is true. And that is called the linear pair postulate. And again, we call it a postulate because it's accepted without proof, because we're dealing with lines and we can't technically define a line. If we know that they're a linear pair, how can we find the value of x? And so I'm not going to really pay attention to what's written here. I'm just going to do the problem. And so we have angle KPL right here equals 2x plus 24. Angle JPL is 4x plus 36. So we know it's a straight line, it's a linear pair, they are supplementary. So they equal 180 degrees. And so it says, how can you check that KPL is 64 and JPL is 116? Well, we need to solve for x. And so 2 and 4 is 6. 24 and 36 is 60 equals 180 degrees. We're going to subtract, I don't think it's 60. Is it 60? Yeah. Subtract 60, and we get 6x is 120. Divide 6, x is 20. Let's substitute. We got 2 is 24. X is 20. We're going to get 40 plus 24, which is 64 degrees. And that is what it told us. We've got 4x plus 36. 4 times 20 plus 36 is 80 plus 36, which is 116 degrees. Woo! So we know that is true. It works. All right, awesome. All right, last problem on this page. It says use an angle bisector. So an angle bisector just cuts the angle in half. It's just like a line segment, but an angle bisector is going to cut the angle exactly in half if this is the bisector. Okay, it makes this angle equal to this angle. So KM is going to bisect JKL. So here's KM, JKL. JKL, the entire thing is 72 degrees. Last piece, and we have this whole thing was 72 degrees. So JKL is 72 degrees, but I know that it's a bisector. I know that KM is cutting that angle in half. So what I know is that JKM is 1/2 of JKL. Remember, you got to make sure that's a bisector, angle bisector. So we know that JKM equals MKL because that's the definition of bisector. They add together because that's the angle addition postulate. Two times JKM equals that because that's what 1/2 means. Okay, so what we know is that 1/2 of 72 degrees is going to be 36, which is going to be the measure of each of those angles. And that's angle bisectors.